try and solve this trig integration question on the screen before I do. While you do that, I wanted to note quickly that there are 25 days left in this maths countdown series. So make sure you stick around to see what I'm counting down until. Alright, so let's get straight to this integral. So the first thing I've noticed is that sine is to an odd power. And that's very convenient because we can take out one of these signs and we can make our integral sine squared of x times by cosine to the fourth power of x times by sine of x dx. And what I essentially did was split the sine cubed of x into sine squared and sine. The reason why that was very convenient and useful is because I can now express this sine squared using my identity in terms of cosine, and I can then have my integral fully in terms of cosine except for the sine. And that's very useful for the following reason, and I'll explain to you. So first let me convert this to 1 minus cosine squared of x. You can see that's the same because sine squared of x plus cosine squared of x is equal to 1. Right, then that's still multiplied by cosine to the fourth power of x. And then, of course, we keep the sine of x dx. Okay, so I said that it was useful to now have it in terms of cosines for the following reason, for the substitution. So if I let u equal to cosine of x, then the derivative of u in terms of x is going to be negative sine of x dx, because the derivative of cosine of x is negative sine of x. So I can take this negative across, and I have negative du is equal to sine of x dx. Okay, so continuing with my integral, I substitute in u for cosine of x, so I have 1 minus u squared into u to the power of 4 times by. Now for sine of x dx, I'm substituting in negative du. And that's essentially the reason why it was so useful to keep this sine of x out here. And the reason I could do that was because sine of x was to an odd degree. And because it was to an odd degree, I could take out one of these signs and still have an even degree of sine. And then my even degree of sine, I could convert nicely to cosine. So I could have this fully in terms of cosine, so that when I substitute, it gets rid of this very easily. And it expresses my integral nice and neatly in terms of u. Alright, so expanding this out, we get the integral of, now u to the power of 4 times by negative 1 is going to be negative u to the power of 4. That negative distributed is positive u squared times by u to the power of 4 is u to the power of 6. And that's, of course, du. So solving this integral, we get u to the power of 5, negative u to the power of 5 over 5. I increase the exponent by 1, and then I divide it by my new exponent, and then plus u to the power of 7 divided by 7. So I increase the exponent by 1, then I divide it by the new exponent. And of course, plus c, our constant of integration. But we're not done there, because we need to express our integral in terms of x and not in terms of u. So every time I see a u now, I'm going to substitute in cosine of x. So we have negative cosine to the 5th power of x over 5 plus cosine to the 7th power of x over 7 plus c. And that is the integral solved. I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.